talk about today? Yes, we're live.
Oh my god, I love the little notebook in your pocket.
Yeah.
Oh, that's so cool. Oh my god.
It's been there all year. How have you not noticed?
I don't know. Because usually I come in and I'm tired, but today I ate breakfast.
You guys don't even notice when I get a haircut. You guys don't even notice when I'm wearing new shoes. Like,
I've been wearing those shoes all year.
well, yeah, usually I don't really have that many shoes to go around. But anyway, back to this. So, first and foremost, most important announcement, especially for those that are online, and especially for you that are in here that need to bring stuff in. Wednesday, I will not be here, as I've been prepping you for multiple class periods. And I've been prepping you mainly because I needed people online to know there will not be a live stream on Wednesday. And if there's not a live stream on Wednesday, what are they to do in order to get credit for being in my class? Well, on Wednesday, when class begins at approximately 9:28, there will be an assignment that will have been scheduled to be released on Google Classroom that you will get on your Chromebooks and that you will take care of for me. Once that assignment is taken care of and submitted, that will count as the attendance for the day. Obviously, there should be a substitute or teacher covering the class, which will cover your attendance. But what about for those online? For those online, they have to take care of that Google Classroom assignment, and that would count. Of course, you guys would have to take care of that as well. Next, I assigned you a project last Thursday, and I understand people being like, yeah, I'm not going to work on it right away. Totally get that. Do not leave it for the last minute.
When's it due again?
It is due Tuesday the 23rd. It's due Tuesday the 23rd.
Oh, so a week from tomorrow.
Mm-hmm.
How many of you started?
0. You know how I know?
How?
No one has contacted me about their car or their house.
Okay, cool. I thought it was the only one.
Yeah. No, because the thing is, in order to begin working on the car and the house, you have to get approval from me. You email me with the name and the year, the make, the model of the car. Mind you, I need all 3 pieces of information and the address of the house so I can add it to the Google Sheet list so that if somebody else goes on that list, they can be like, oh, well, that car is taken. Keep in mind, different years are different cars. So if somebody decides to do a 2007 Toyota Corolla and someone else decides to do a 2008 Toyota Corolla, those are 2 separate cars, and I would be fine with that.
What if they're the same exact price?
Well, if they're the same exact price, they're different ages. And because they're different ages, they'll get different results. Yes. Trust me. The only thing is with the banks you don't need approval for. You just need to be researching 3 different banks and make sure that you have screenshotted evidence. Website reference to find them. Joe, great question. Website references to find them. On the actual project PDF, there are website recommendations that you could use. So I've already taken care of that question preemptively. So make sure you are checking that classroom assignment for the project. Make sure you are emailing me to get approval for your car and your house. You do not want to wait for the last minute. So watch, it's going to be Friday. I'm going to see you guys on Friday, and I'm going to say, hey, don't wait for the last minute. And then it's going to be due on Tuesday, and I'm going to get a bunch of emails on Monday night. Yeah. Saying, can I do this house or can I do this car? Happens every year, despite me telling you guys, don't wait for the last minute. Well, I'm saying it now because it's just across the board, everybody. But keep in mind, I totally understand. Like you just said, the project's not due for what? A week and a day, right? Yeah, totally get that. Don't wait for the last minute. Yes? No. Unfortunately, that's all I got. Sorry. I don't have anything other than that. So, as for today, I'm sorry, I can't help you there. As for today, we are going to be getting into some of these logarithm properties. Actually, Madison, you asked me about it last week, like some of the different rules that can go along with like logarithms and stuff. And I said, like, hey, we'll see that stuff on Monday. Today's Monday.
Also, you call me Maddie, not Madison.
Why?
Does Madison is so formal.
All right. Sorry, I can do that. It's probably going to be habit because I have a niece named Madison, and we've always called her Madison, so that's usually what comes out of my mouth.
Think about how different I am from her, and then you could.
Not that different from her.
Actually?
She's in like her early 20s.
Oh.
Anyway,
Is she cute?
this conversation is going off the rails.
Okay. Never mind, I guess.
Ladies and gentlemen, if you would, I'm going to need those notebooks out and open.
Oh my god.
Oh, sweet. That's what you needed, right? Yeah.
You're literally the best ever.
John, to answer your question in the chat, yes, you do. You do have to pick a car and a house according to the directions you were to email me. The year, make, and model of the car and the address of the house so that you can get approval for it so I can add it to the list because no one is going to have the same house and car. If you have not left a comment in the chat, please make sure that you do so. I will be checking it temporarily, or soon, I should say. So we can get into this. Okay. Now, today is going to be a bit more note-driven than past class periods, mainly because since I am not going to be here on Wednesday, I need to get you this information so that you can practice it on Wednesday, that is. And we kind of move forward with this. So this is going to be properties of logarithms. I am probably one of the few math teachers in the world that hate Pi Day. Absolutely hate Pi Day. Pi, yes, I see its importance, but there are far more important numbers than pi. One of them being, I teach this in a different class. I actually teach this in discrete math. For one chapter we cover the number phi, P-H-I, which is far more important than pi. Well, the number pi is a bit more graspable for students, mainly because you learn it in middle school in geometry. And you learn it as the ratio between the circumference and the diameter of a circle. It's a bit more graspable because everyone kind of knows what a circle is. You understand the concept of a circumference going all the way around. That distance divided by the diameter is pi. Yay, graspable. So they make a big deal out of it, and people make, pi-shaped things, and on Pi Day, we all celebrate pi. But pi, in my opinion, is such an inconsequential number. Because what in life is actually truly a perfect circle? Very few things. Wheels. Right? Maybe other things. Who the heck knows? But phi is much more important. Now, I'm not going to get into the details as to what the number phi actually is and how it's calculated. But let me just tell you that the number phi is embedded in your DNA, literally. In the spiral of your DNA, it is actually embedded in the ratio of the spirals. Question? Yeah.
Oh my God, I'm learning science class.
Well, that's one thing there. Number two, you talk about think about a flower. Petals come off that flower, or not petals at the top, but like little flower, like green flowers come off the stem, right? They grow out in a spiral in the ratio of phi. The number phi is a ratio that is actually hidden within the human body. Leonardo da Vinci knew about it. You know the painting of the Vitruvian Man? The guy with his arms out? Hold on, announcement.
Mrs. Berserk, please call the main office. Katie Berserk, call the main office.
Yeah, that's phi. But anyway, phi is for another class period. The other number that's way more important is the number E. You ever hear the number E? You have. Oh, he was nodding yes for a second. Weird. What an amazing statement that was. Yeah. Well, let me show you how important E actually is. Where's my calculator up here? Here it is. Check this out. Because I don't like pi day.
Like, look, I understand, but if phi is that important,
You're just.
Yeah, probably.
we can have a pi day and a phi day.
No. Now listen. Right down here at the bottom of your calculator, it's a little hard to see. I'll move it up a little bit more. Here we go. In my calculator, it's in yellow and yours is in blue. Of course, you have that pi button. You guys know that pi button's been there the whole time, right? Yeah. And you know what pi is, of course, if you hit second and then that number, bring it down to this screen right here, you get this number pi, 3.14, blah, 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 blah. Doesn't matter. Don't care. What's more important than pi, look where I'm pointing, is E. It's just as important, if not more. The number E is a number that we are going to be investigating a little bit today because of its relationship to logarithms and exponentials. E does not stand for exponential, by the way. E does not stand for exponential. We'll talk about what it stands for, but we will be talking about this number today. This number, boom, 2.718.
So February 7th.
Well,
2018.
I know. Now, this number has way more to do with life than pi ever did. It has everything to do with the stock market. It has everything to do with business and finance, compound interest.
Did you say finance?
Finance.
I thought you said finance.
I think you got pi on the brain. We're going to be talking a bit more about that. I have a short, 2-minute video to show you when we get there. But we will be talking about that today as well in the properties of logarithms. We're going to get there. It's going to be fantastic. For me, not for you, but mainly for me.
So on the side of my notes, I'm going to write F5.
Nice.
Just so I can remember this exact stuff.
Okay. Back to this.
What's the number 5?
The number 5 is approximately 1.618. In fact, if you Google it, number 5, now when I say phi, PHI, it's approximately 1.618, and it is probably the most important number in human existence. But I don't teach about that here. I teach about that in discrete math, if you are interested in taking that next year as a half-year elective. Just saying. It's only a chapter, but we cover other things in that class too. Look at me advertising. Anyway, back to this. First, let's talk about your basic logarithm example right here. This is something that we have been covering for multiple class periods now. But I want to point something out here about the base. The b is the base. The base on the logarithm is the same base that is on the exponential. There is something known as the common logarithm. The common logarithm. And when I refer to the common logarithm, I am referring to log base 10. If I'm referring to the common logarithm, I am referring to base 10. Now, when you see a logarithm, typically there is a base that is written as a little subscript. That is how it typically is done. But if you look at the logarithm button that is on your calculator, I'll come back to that thing in a minute, but if you look at the logarithm button that is on your calculator, look at that thing on the left side of your screen, you notice that there's no little subscript on that word log. It's because that log button is automatically set to base 10. Hey, remember I mentioned E before? Look what's underneath the log button.
Holy crap.
It's so important, it's on 2 different locations on the front of your calculator. We'll come back to that.
It's getting fun.
All right. I'm just saying, it's so important, it's on 2 locations on your calculator. That's insane. We'll come back to that. Even this button as well. You see this button right here? We're going to come back to that button too, because that button is also a logarithm. We will. Now, this common logarithm, again, they refer to it as the common logarithm, but when they write it, they actually typically don't even put the base on there. Sometimes they don't even have to put the base. Don't have to write 10. If there's no number there, you assume it's a 10. You have to. Maddie, your hand was up for half a second. Sure. 2 seconds. I gotcha.
So, do you use printer paper to write your notes?
Yes.
Sorry, this is really great, but approximately how many sheets of paper do you go through a day?
A day, I probably go about 5 or 6 a class on average.
That's all. I know.
No, that's okay. In fact, you see all these binders back here?
Yeah.
Here are the notes that I've taken in your class so far this year.
Oh, cool.
That sounded sarcastic.
No, actually, listen, I thought you were just gonna kind of toss them out.
No, heck no. I keep everything. I keep everything mainly for the reason of if anybody has a question or, oh, Mr. Markey, I didn't get these notes back here, or if I need to reference something that we covered, I always have a hard copy.
I appreciate it.
Yay. Anyway, back to this. So you don't actually have to write that 10 there. If there's no number, you assume it's a 10. Now, you've actually made a lot of these assumptions in your past mathematical classes. If there's no number, you assume a lot of different things. For example, if I write this, what do you automatically assume that symbol is? You assume it's a square root, even though there's no number written there. Absolutely. You assume that kind of stuff.
Okay, I'm really sorry.
Sure?
Or you say you have to assume that there's a 10 there.
If there's no number there.
If there's no number there. If there's no number there, it's always a 10.
Correct.
Always, no matter what. There's no silly rules. If there's no number, it's always a 10.
If the word log is there with no subscript,
Okay.
you automatically assume it's a 10. Yes,
You say assume. Always assume?
always. Just like you always assume this is a square root. Yes. No, it's a good question. It's a good question. It is. Like I said, the button on your calculator automatically is just log. You assume it's base 10. Now, where this comes into play, we've done this before. We've done this before with base 10. I want to write it down again. Again, this whole idea of today is based on the properties of logarithms and how they relate to one another. You have something called the change of base formula. You have something called the change of base formula. And what that really comes down to is this. Log base b of y, I'm not changing any of the numbers, is actually equal to the following calculation. And again, you mentioned before about how if I didn't write a subscript, right there. That fraction, there's no subscripts. There's no subscripts whatsoever. Let me move that up a little bit for the people in the chat. There's no subscripts right there. So as a result, you should assume that that is log base 10, meaning you can use the button that is on the front of your calculator. Now, you guys have it kind of easy because you have the calculators on your Chromebooks, but you don't always have the calculator on your Chromebooks. You don't always have it. But you do have calculators on your phone, correct? Don't all phones come with like the little, stupid calculator? Again, I'm going to brag about myself. For the first time in 6 years, I have a brand new phone.
Wow.
I know, 6 years.
That's exciting.
Yeah, I had a Galaxy 7. Yeah.
I don't know what that means because I'm an Apple person,
Well,
but I'm extremely happy for you.
Okay. So here's my calculator right here. The dumb old calculator that comes with it. But as you always know, if you turn it to the side, you do get right there on my phone calculator, if it'll focus. Come on. Let me zoom out a little. Maybe it'll work if I zoom out a little. There it is. Kind of. But you see it there. It's log. By the way, the thing that I'll also point out, this is my phone calculator. Look what's also there. ln. Remember that ln button we talked about? Look what's also there. E. By the way, check this out. Remember we talked about pi? E is right here, right? It gets 2 buttons? What the heck? But anyway, we're going to get there. We're going to get there. But I'm just saying, even if you don't have your graphing calculator, even if you don't have the computer calculator, you can still calculate logarithms because you have the button on your phone. It's there. My word, it's so crazy what they put on your phones nowadays that you don't even use. Now, so one example that I can use with this change of base formula. Example, let me do not a silly example, but a basic example. Log base 4 of 64. Now, I need you to think about log base 4 of 64. And listen to the following question. 4 to what power will give you 64? 4 to what power will give you 64? It is a nice whole number. We just go down the line. 4 to the first power clearly is just 4. That's not going to work. What's 4 to the second power? Oh no, we forgot. Did we forget? 4 to the fifth? Zooming in, zooming in, zooming in, zooming in, zooming in.
No, is it 4 to the third?
It is 4 to the third. Yes. For the record, 4 squared was 16. Okay, great. But the answer should be 3. The answer is 3. The answer is totally 3, but I'm not going to write a 3 just yet. I'm not going to write a 3 just yet. Instead, I'm going to write this. This is, again, if you don't have the fancy function to be able to do log base on your calculator, you still have a log button. And I'm going to show you this on the calculator in a moment. I'm going to show you this on the calculator in a moment. So let's see. If I were to go to my calculator and I were to do log of 64, by the way, look at log of 64. Look at that number right there. Look at that number. And if I did log of 4, look at that decimal craziness right there. Think about the insaneness of what I'm about to show you. Think about the impossibility of what I'm about to show you. You told me the answer was 3, and it is. The answer is 3. And according to the change of base formula, if I were to take those 2 decimals and divide them, it should get me exactly 3. Now, at first glance, think about what division does. You're taking this impossible decimal, you're dividing it by this impossible decimal, and somehow the answer is 3? That doesn't seem likely. What? Say again? Right? But look what happens. Look what happens. Log of 64 divided by log of 4. Notice I had to close the parentheses around the 64. Gives you exactly 3. It is insane how it works. But that's what the change of base formula allows you to do. I'm going to show you a bit more properties with that in a little bit. But that answer is 3. Okay. Let's see what we can do with this. I'm going to put a little note here. Yeah, I'm going to put a little note here. It's not, an actual like star. It's just going to be like a little asterisk right there. For the following properties, you can assume the same base for all logs. You can assume the same base for all logs. That's important to note because you're not going to be changing the base mid-problem. You are not going to be changing the base mid-problem. If there is a base on one step of the problem, on the next step of the problem, you need to make sure that you replicate that base. The base is not going to change. Let me show you the first property, and then let me show you how it works. There we go. There's the first property right there. I want to spend a little time with this property. Just kind of talk about how the heck it works. Now, again, notice the little b right there. The base is not going to change on these properties right here. So if you have a b as a base on the left, you have to keep the b as the base on the right. Please make sure you realize that. I don't know what the protocol is for that.
There's nothing here.
I know. We haven't been given any further instructions in regards to the dividers. My opinion is one thing, but a supervisor walking by and seeing that as a student sitting at a desk without it is going to be on me. I know. It would be me getting in trouble. I know, I'm sorry. Yeah. Now, the way that this property works, give me any two single-digit numbers. Any two single-digit. 2 and 4. Yay, we did it. Great job. Okay. 2 and 4. Watch what I'm about to do on this calculator right here. Zoom in, zoom in, zoom in, zoom in. I want to show you what the calculator does, and then I want to show you how the property relates to it. You said 2 and 4, right? Log of 2 plus log of 4. Now, I'm doing the regular log button on the calculator, so this is base 10. That's not the point at the moment. But log of 2 plus log of 4, crazy decimals. Crazy decimals. Just all over the place, crazy decimals. It doesn't really matter what that crazy decimal is. But what matters is this. 2 times 4. 2 times 4 is 8. Look what I have typed up there. It's the exact same decimal. This is called condensing logs. Ed? Go ahead. Well, no. What's 2 plus 4? That's true, but there is a plus sign separating them.
Yeah, positive log, positive log, positive log. That's how I look at it. That's how I see it.
Well, check this out real quick. You ready? Log of 2, again, by itself is that decimal. Doesn't matter what that decimal is, you can see it. Log of 4 is that decimal. You'd still have to add those decimals together to get log of 8. It's a little weird. I know, right?
Can you type in the last one again?
Log of 8. It's a little weird. There are various problems that I'm going to show you eventually that come into play with this thing. Well, that's how this thing rolls out. Let me show you the property again. The way that the property basically works is this. If you have two separate logs that are being added together, as long as they are the same base, that's why I put that note at the top. As long as they are the same base, if you are adding these logs together, you can combine them into a single log where you simply multiply their innards. It's a strange process. Check this out, though. You could pretty much guess as to what's going to happen next. Based on what I just showed you with the first property, you could guess what's going to happen next, and you would pretty much nail it. What happens if I divide the innards? How would I separate those logs? Ooh. Well, let me walk you through the logical progression here. If I multiply their innards, I could separate them by adding.
Oh, subtracting.
Exactly. Or if I'm adding them, I could put them back together by multiplication. If I'm dividing them, I can separate them by subtraction.
And vice versa.
Exactly. And if they're separated by subtraction, I can put them back together. Their innards would be divided. Now, mind you, their innards would be put together. Their innards. I'm being very specific with that word. You ever seen, I'll tell you a story. My sister lives out in Pennsylvania. I've talked about her house being like 150 years old. She married a guy that grew up in the middle of PA who pretty much, he's so used to doing all sorts of like, manly things in the woods. So the first kid they had was a girl. They had a girl, my niece, Danae. And when she was like 5 and 6 years old, she went out hunting with her dad, like legit hunting. And it was one of those things where like they killed a deer. And so he dressed the deer. I don't know if you guys understand what it means to dress the deer. Skin it,
Yeah.
cut it open, gut it, get all the meat out, dry it out, that kind of thing. Yeah, he did all that. And so 5 or 6 years old, I heard the story. She walks into the kitchen one time and she's like, Daddy, I'm a deer. Like a 5 or 6 year old girl would do.
Yeah.
And then she says, shoot me. So he, pretends to take out a rifle and shoot her.
Yeah.
So she falls to the ground and then she's laying there for a little bit. Now cut me open. Like, whoa. So flash forward. My niece is now like 12 or 13, right? We're visiting for like Thanksgiving weekend and stuff like that. Now I'm out of the house at the time. I don't know where I am. I think I went to the store with my sister or something like that. We come back and my wife tells me, Danae, 12 or 13 years old. She's like, Danae killed a bird. I'm like, hold on one second. Hold on.
Excuse the interruption. Connor Donahue, please report to main lobby. You're being signed out.
She's like, Danae killed a bird. I'm like, what do you mean she killed a bird? She took out a bow and arrow. She tracked a bird.
What?
She shot it and killed it. I think it was a dove. And I'm like, cool. So what'd you guys do? Oh, well, she took the bird. She got off all the feathers, gave it to her dad. He cooked it and we ate it for lunch. I'm like, what?
That's impressive.
Yeah, it kind of is.
That's like actually really impressive.
So, innards, dead animals. That's the connection I'm trying to make. If you're talking about the innards, you're putting the innards together, not that you're actually multiplying multiple logs. You're putting the logs together into a single log by multiplying their innards. Or if the operation is subtraction right here, you're putting their innards together by dividing them. It depends on what the property is. There are these two main properties right here that's going to help you either condense or expand logarithms. Those are two very big properties right there. Here's another big property for you. One more big property is when you have an exponent. That exponent is allowed to travel. That exponent is allowed to move. But it's only allowed to move back and forth between two places. N, the letter N. Exponent N. It's only allowed to move between two places. Where it is in the exponent and right there as a constant that's being multiplied by the log. That exponent of n is only allowed to move between those two places, right here in the exponent or right here as a number being multiplied by the log. Tell me, besides the n, what happens to everything else? What happens to everything else besides that n? No, nothing cancels out. I'm saying besides the n moving, because the n is going to move around, stays exactly the same. I just want to be clear about that. I want to be very clear about that. Notice the base, as I wrote with that asterisk earlier, the base does not change. It's just the n that can either move from the exponent down to be a constant, or it can go in the opposite direction. It can go from that constant coefficient and actually jump up to be the exponent. Mr. Markey, why would you want to do that? Well, depending on the problem that they're asking, you may have to go in one direction or the other. We're going to utilize these properties in a little bit. We're going to utilize these properties. I have a couple of sample problems to show you. I just have two more very basic things to show you right here. Yeah, but it's like a 2-minute video. Once I get to E. Once I return to E. Like I said, since I'm going to be out on Wednesday, I needed to get you all this information. Maddie, this is what we talked about the other day, this property right here. We talked about that on Thursday. Do you remember what we talked about? I didn't actually write anything down in our notes.
I know, but I did.
Oh my goodness.
Are you waiting for me to pull something up?
Oh, I thought you were looking it up.
Trying to.
Oh, my bad.
If it confused me, then I don't know if it's here.
I got you. Well, let's just put it like this. Remember how log base b is the logarithm, and this base is the exponential. If the base on the logarithm matches the base on the exponential, they cancel each other out, leaving you with 1.
Oh, I remember that.
Yeah. Yes.
I need a pass.
Mm.
Oh,
Do you?
I'll just go.
Now, this other property right here, log base b of 1. I want to talk a little bit more about this. Actually, I want to talk about both of these. The first one is because b to the first power equals b. And the second one is because b to the 0 power is equal to 1. That's why those two properties are there.
Can you move them down for a second so like I can see what you wrote prior to that?
Oh, sure. Hold on. Let me overlap the pages a little bit. I know it seems like a lot of properties being thrown at you, but a few of them, at least the last two, not necessarily needed to be memorized, but it's one of those little quirks where if you ever see it, it's like, oh, b to the 0 power is 1. Oh, that means b log base b of 1 is always equal to 0. But the because is very important because it shows that relationship between logarithms and exponentials. Okay. I'm going to leave this up here for a moment, but I am going to show that video next. Because I do have to get back to E. Okay. E has everything to do with what we've been talking about with logarithms. E does not stand for exponential. E was actually named after the 18th century mathematician Leonhard Euler. Euler was a very interesting guy. He went blind in one eye at a very young age. And by age 30, 35, he went blind in both eyes. But he continued doing math until like his 70s or 80s. Now think about that for a second. One of the greatest mathematicians of the 18th century, completely blind, unable to see what the heck he's doing, had to visualize all of the mathematics in his head.
I can't imagine that. That's like doing mental math.
Yeah, but he did it. For 40 years of his life, he was the greatest mathematician of the 18th century, and he did it in his head.
That's crazy.
I know. His son wrote down everything that he wanted him to write down. He was like, like a stenographer or whatever, But E has stood the test of time. 1 second. Where'd the video go? I had a link up, and that link got closed out. It should be in my history.
Also, for everything we just learned, so we have the multiplication subtraction. I could put that in its own little property. Then I could put exponential property, and then
Well, actually, you know what? Let me go back here real quick. Because this is why I have the concrete notes, right? So I can always go back if I need to. No, that's perfectly fine. But this is why, because if, I don't have to worry about erasing anything. You know what I'm saying? So yes, these two properties are technically like related to each other. Absolutely. You can kind of put them together.
if I were to have a name for them, just like
These three properties in general have to do with logarithm expansion and condensing is what they call it. It's called expansion and condensing. If you were to expand a logarithm, that means that you would actually go from the left to the right, from what you have written here. Because expanding is like you just make it like longer, you stretch it out. Condensing is when you obviously put things together, you make things smaller or shorter or things along those lines. And the way that I wrote the property is condensing would be going from the right to the left. So the other properties that I wrote down on the following page, they're just like simplifying properties. Yeah. So let me show you this video real quick. Let me put the microphone in front of the speaker. Let's see what we got here. It's a short video.
Made a video about pi, the ratio of a circle's circumference to its diameter. But there's a less famous, but equally fundamental number known to anyone who's taken high school algebra. It's about 2.718281828459045, and so on. And it was first defined by Jacob Bernoulli, but later Leonard Euler called it E, and the name stuck. Bernoulli first defined E through compound interest. Now,
compound interest. Interesting.
compound interest says that you get a little bit of money in interest every period, and that money you gained helps you gain even more interest next period. In other words, your interest compounds. So if you stick $1 into a bank account with 100% interest rate compounded annually, you'll get $2 at the end of a year. If it's compounded semi-annually, you'll end up with $2.25. Quarterly, and you'll end up with $2.44. Monthly, $2.61. Weekly, $2.69. See where we're going? If you increase the number of compounding periods a year towards infinity, then you'll get closer and closer to E dollars. In statistics, it describes the most important statistical distribution, the normal. In biology, it models populations of species through the logistic function. In physics, E describes the exponential decay of a radioactive material. So, while E may not be as famous as pi, it's easily as fundamental and immensely important.
Now, as I said, E is a very important number. I'm not going to go over the details as to how E was discovered because that's not the point of this. The details involve a lot of repeated fractions over and over again. But I can tell you this. E was mainly discovered.
so is this like a new section with my notes?
No, this still has to do with logarithms and properties of logarithms.
Well, correct.
Yes.
Like, if you have property of logarithms,
Yes.
change your base forms up, and this can go in
Technically, this is going to be a property of logarithm once I finish the little definition of E. E was mainly discovered through the compound interest formula, which we've been covering for quite some time. E is approximately equal to 2.71828 ... It goes on forever. You can find out, well, you can have it as a number in your calculator in those locations that I showed you. And I'm going to bring up my calculator on the screen in a moment so that I can show you again, kind of point out where it is. If I bring up my calculator right here, boop. Obviously, well, hopefully you know where pi is right there on the graphing calculator. But if you hit second and then the division symbol, you actually get to that number E. The one down here does open up an exponent. So if you just want the solitary number E, if you hit second and then division symbol and then enter, it would spit out that number, second division 2.71828, et cetera, et cetera, et cetera. It goes on forever. It is what they call an irrational number. It's irrational because there is no pattern to it. There's no repeated digits that keep repeating forever. There's no fraction that you can write this as. It's a number unto itself. Now, this. What did I call, or what name did I give to log base 10? What name did I call log base 10? Common. Common is like everyday. Common is like very ordinary, right? When you hear the word common, it doesn't really spark illumination or something like that. It's like, common, everybody's got one, right?
Like when you get like a collectible item, it's like common, rare, ultra rare.
Exactly. Check this out.
What? That's a good way to think about it.
Then we have what is known as the natural logarithm. E is so fundamental that the name that they gave log base E is the natural logarithm. That's what they call it. You actually have, remember I talked about that button on your calculator. You have the log button. Do you remember what button's underneath the log button?
E.
Well, technically, but do you remember the letters on that button? ln.
LM and then E.
Well, that's your natural logarithm. Let me show you what I mean here. Actually, no, let me show you here. If you go ln of, let's say, 8, it's basically saying, well, hold on, where's my marker? There it is. Log base E of 8 is equal to that decimal. What they're really saying is, well, E to that decimal is equal to 8. That would be the exponential form of it. I'll show you on the calculator. If I did E to, I'll just type it out, 2.079441542. Keep in mind that decimal would go on forever, but it's approximately 8.
What?
I know.
What?
I had to round it. If I want to get the actual answer, I can do this. Check this out. ln of 8, and then I could do e to the power of the answer, and it would spit out exactly an 8. It's pretty messed up. It's so fundamental. They gave it its own button on the calculator, not once, not twice, but 3 times. Not only as an e to a power, not only as the constant e, but also as the natural logarithm. I know. Now, they call it the natural logarithm, but they've also given it its own notation. They've also given it its own notation, ln of y. ln. Somebody asked me the question that they need to ask me. ln, natural logarithm. Actually, it's Latin. Logarithmic naturalis.
Okay, so I was right.
Yeah. Well, the question I was going to ask was mainly like, why are the letters backwards? Yeah.
Perfect.
I know.
That's so stupid.
Why?
Why is there just NL?
I know. That's the notation that was originally given to it in the 1700s. And that notation has permeated to today.
Well, understandable, but just like a language changes over time.
Mhm.
Why would they just do it?
Language may change over time, but the notation that usually we do for mathematics typically doesn't.
He hates English because English doesn't make any sense. Math makes sense. And math doesn't.
Oh, no. I love English. I love reading. I love wordplay. I love puns.
But
English is a made-up language. Yeah. The way that mathematicians decide to describe mathematics has to be done through language, whether it be English or German or whatever. Or Latin, if you will. But we end up with some junk like this.
the
Now,
moral of the story, it should be NL.
well, by today's standards, yes. You know. So check this out on the calculator. I'll show you this. You know where the log base button is, hopefully. If you hit math and you go to log base, I can type in E as the base. And give me a 2-digit number. 48. Check this out. Clearly, log base E of 48 is that decimal. Because E to that decimal is 48. Yay! Well, couldn't I just done this? It's the same thing.
Oh!
It's the exact same thing.
Log E and
ln,
are the exact same thing.
correct.
Oh.
Yes.
Then what's the point of having 2 buttons?
I don't know.
So there's no point.
Well, the calculator has like multiple buttons doing the same thing.
But that doesn't make any sense.
I know, but that's how important it is. It's so important. Think about that for a second. E is so important that you could perform the calculation under log base E. You could perform it under ln. They give it its own dedicated E button. How many buttons on the calculator are dedicated to pi?
One.
Just one.
That just, see, my whole thing with that is it doesn't.
So the moral of this class, pi is useless.
No, pi is not useless.
It's
Pi is just not as important as people make it out to be. The reason why I bring that all up today is because of yesterday. Yesterday was Pi Day. What a dumb day.
So
So hold on. Let me put this on here, under here. Same thing. They're the same thing. Yeah. I have one more thing to write down, but you were in the middle of a question.
it was probably something stupid. I don't remember. So if it comes up again, I'll ask.
Well, not all questions are stupid. I will agree that there are some questions that are stupid. But I would rather say silly questions deserve silly answers.
I don't think silly's the right word either. Like when I think silly, I'm like, that's silly. But it was probably more going to be like a non-intelligent question.
Remember the following. A equals P parentheses 1 plus R over N to the NT power. We wrote this down multiple class periods ago. Write it down again. This is a formula that you will be using for your project on the bank part. Yes, absolutely yes. N is the number of times compounded per year. We've done that. We've seen that. Most banks compound monthly. It took us a while to find the TD Bank information, but we found it. Some banks compound quarterly or daily. It depends on the bank. But they compound a different number of times per year. That changes the value of N in this formula. If we were to compound continuously, now what do I mean by continuously? Think of it this way. I could compound annually. If I compound annually, how many times is that a year? I literally just asked how many years are in a year. Yeah, what is it? One, yeah. If I compound monthly, how many times a year is that? 12. If I compound daily, how many times a year is that? Yeah. Obviously, we're ignoring leap years. You know, I could compound hourly. That's the number of hours in a year. Or I could compound every second. Or I could compound every half a second. And I can keep compounding more and more and more and more and more times a year. But when I say compound continuously, I need you to imagine this ridiculous situation in your head where every moment, oh, I'm not done yet. I still have one more thing to write down, guys. Every moment of every second, of every fraction of a second, of every millisecond, your bank account is compounding and compounding and compounding and compounding. It's compounding like an infinite number of times a year. It's a ridiculous situation. But if it's compounding an infinite number of times a year, I don't have a number to plug in here. I don't have a number to plug in for N. I don't know what N is, which is why it was discovered that if you are compounding an infinite number of times a year, you have to use the following formula. It's called the PERT formula. A equals P times E to the RT power. On Wednesday, you will be getting some basic practice with this, as well as working on your project. Make sure that you follow the directions in Google Classroom. If you have not commented in the chat, please make sure that you do so. I'm going to be signing off in a minute and running down to study hall. Recommendations for the project. If you go to the PDF that I provided for you guys, there are a few recommendations in terms of resources. For the bank, I even said you can't use TD Bank. So you guys, on the PDF, it does say like Bank of America, Chase Bank, things of that nature. Again, not the only things you're limited to. For the car, I suggest cars.com, Auto Trader, Edmunds. For the house, you go realtor.com, Prudential, Tarbell, Century 21. There's a whole bunch of different things, but they're written on the actual PDF of the project. So, yeah. I'm going to have to sign off, guys, because I got to get downstairs. See you guys. Have a good one. Bye-bye. No.